what is the inverse? This is a very good question to ask. And the answer is, right off the bat, it is the matrix which you, ignore this part, the matrix which you multiply R by to get the identity matrix, which is ones on the diagonal and zeros everywhere else. So this is the answer, but this still does not answer your question about R inverse for this matrix. And the second note that I have here should do just that. So as a general fact, if you have a 2 times 2 matrix, and this is special to 2 times 2 matrices, you can find the inverse simply by flipping A and D and switching the signs for B and C, if this is A, B, C, and D. But don't forget to divide by the determinant of your matrix. So if we do this for the matrix R, then R inverse is going to be switching the cosine with the cosine. Oh wow, they're still the same. And this becomes positive, this becomes negative, because I multiply by -1. And I divide by the determinant of R inverse. The determinant of R. What's the determinant? The determinant of a matrix A is AD minus BC. So let's compute the determinant of R on the side. It's going to be cosine times cosine squared of theta, minus sine times negative sine times negative sine. So sine times negative sine theta. So this is nice because the minus becomes a plus, and sine squared is just sine squared. Sine times sine is sine squared. Now, final question. What is cosine squared of theta plus sine squared of theta? Does this look familiar? Hopefully it does. This is just the Pythagorean identity, where you have theta, you have a triangle with hypotenuse 1, then this is, this is sine of theta, and this is cosine of theta. Pythagorean identity. But anyway, so this is always equal to 1, is what I'm trying to say. And if this is equal to 1, then, this is just equal to 1. Maybe use this color. Blue looks much more fancy for some reason. And then you're just dividing by 1. Then your matrix is just going to be this one. You don't need to worry about the determinant. And as a bonus fact, this is what is called a rotation matrix. So it takes a vector in space. It has determinant 1, which means that it doesn't really change anything to the length of the vector. The length of the vector stays as it is. But if this is the vector, for example, here, then it could, for example, rotate it by some angle. I'm not sure what the angle is in this case, but I'm pretty sure this is a rotation by some angle, theta. And this is really all I have to say.